thank you. I want to thank the organizers for inviting us, and in particular Naoko and Ryori. So I will talk about drawing, the activity of drawing today. And I want to emphasize certain aspects of why I think this is a very key activity humans do. So in particular, it's one of the possible ways to express creativity. It is based on a notion of processes, and I will give you some examples a bit later. It is meant to be appreciated, so it is actually an activity which gives a result, and the result is to be observed by the creator or others, which creates interesting questions from a scientific point of view. I want to pitch the idea that it gives us one of the possible ways to study intelligence in humans. And I'll give you examples, and I hope it will be clearer by the end of the talk what I mean here. Also very interesting, I think, is everybody has practiced drawing at some point in their life. When we're a child, we do a lot of our learning by doing drawings of all kinds, and we go through a succession of... Yes, I believe so. Can you hear me in the back?
The interpreter cannot listen.
Oh, but I hear the speakers.
Okay, maybe how about this?
This one? Is this better?
Yeah.
And for the interpreter? It's good? All right. Thank you. So, yes, I was saying you probably all remember, maybe you still draw when you're an adult, or you're an artist, obviously. But you may have abandoned the practice, but you will have done some drawings very intensively for many years, in fact, when you're a child. So it is an activity which we can relate to across all people and all cultures. Then, interestingly, it evolves via culture, so it does change in various cultures and through history. So there's a notion of style and cultural history that is propagated through generations. So that's sort of also an interesting aspect of the activity of drawing that we could study. And also very important for me in my work, and today I will emphasize how the influence of using a body, an articulated body, plays a role in the activity of drawing, and in particular the quality of a drawing. And here's an example of what I mean by a drawing. So this is more of a sketch-like drawing by Spaniard artist Pablo Gargalo. And you see, if you look at the details, you see something quite complicated. So if you zoom on an area of the drawing, you see a lot of flow lines, a lot of possible complexity. And when you zoom out, you get a clear impression of what the artists try to convey. And there's also a notion here of something in movement. So the cavalier here seems to be not necessarily in a static position. And this is all rendered via a few lines. We could actually count them. There's not that many lines there. Here's another aspect of drawing, and here I'm starting to give you examples of techniques or different techniques that are used. So this is called sometimes the line of action. You see that there's a main curve going through the body from the top to the bottom, and this line gives the main pause, the main position of the body. And once that line is drawn, you will then draw the other details. You will flesh out the body with, in this particular case, very rapidly with these sort of circular elliptic gestures. This technique is used a lot in the art of animation, and in particular was popularized by Disney Studios in the 1930s to create a lot of frames, a lot of drawings rapidly. So you would give the main pause of a character over many frames this way. And then details would be added later. Here's another technique, quite different. So this is a more careful study of how to draw a body, but by starting by a description of fine details in terms of primitives, object primitives, something you would encounter as well in technical drawings, in computer design, for example. So this is This is classic. This goes back hundreds of years ago. You can think, for example, of Leonardo da Vinci. That's the kind of techniques that have been around in order to study how to render a particular object, which can be quite complex. And in this case, it's a body, so it's an object we could render in many possible ways, how you articulate the different primitives. So again, we get a notion that drawings can be used to study here parts of an object, and you have particular techniques that have been developed over the years. Here's yet another example from the Pratt School in New York, and here you have different ways taught by Professor Douglas Wills about rendering the notion of sequences of movements. So you see here, you can recognize sketches, very simplified, of different actors in movement, in different kinds of movements. Not yet another technique. So my main pitch for this talk is this slide. So this is the most important slide. And I want to convey the idea that as observers, we can appreciate a piece of art, in particular a drawing. We'll study that in the context of drawings, and associate notions of aesthetics and skill of the person who created the drawing by recovering possible movements that were used to create the traces. And this idea has been studied in the past few decades, and there's quite a few results, for example, in the area of psychology. So people in psychology are running tests with different human subjects and testing this hypothesis that actually, even though you may not know much about how the drawing is done, you can actually give a likely scenario which sequence of movements were used to create the drawing. There's also ideas from neuroscience now, results from neuroscience, where you see areas of the brain that respond when you look at the drawing, which correspond to the same areas that you use when you plan to move yourself. And here's an example in the area of calligraphy, where I think everybody probably can guess a sequence of movements that is very likely similar to the original version by the artist. We have another beautiful example here, art innovation displayed for us, where we can probably guess a sequence of movements and how the brush was manipulated. So that was my main, that's the main hypothesis that we were interested in, and we need to put in place, we're doing science, so we need to put in place a methodology to test that hypothesis and question it and try to come up with ways to study it and understand it. So we seek to model processes that are involved in the activity of drawings. We already have the intuition that that's already exists because of the skills and history of how the art of drawing has developed. So we're trying to uncover these in our studies. We want to break these into this notion of primitives. So we've already seen some examples that are used by artists. So again, very likely we could recover a notion of primitive, but we don't know exactly what it means, what it is. Then, if we can do that, we will produce computational models that we will implement in software. If these results are satisfying, then we go to what we call embodied systems. So we move to a machine, like an actual hardware piece. And in the ideal case, we will try to use what we call a humanoid robot, so a robot that is articulated more or less like a human, and that in particular with the arms and ideally with the torso as well, which plays a role in how you move and how you trace. You lay ink on a piece of paper, for example. So we will go that far, and this will give us a methodology that allows us now to test this hypothesis. The hypothesis, again, that humans appreciate an art piece, such as a drawing, by recovering likely movements used to create it. On the topic of robots and machines in general used in drawings, I think it's also interesting for a number of issues. If you compare it with a pure software version, it mimics a human obviously more closely. It can also be used then by artists in a more theatrical performance, and I'll give you some examples shortly. It introduced a number of constraints that are not necessarily obvious when you're doing purely a software version model. So there are all kinds of constraints about you're actually manipulating something physical. You have to order your actions in a certain way, which again, with a computational model, you can go in pretty much any way you like. And you'll handle a pen. If you have a camera watching what you do, it may get in the way. So you have all these physical constraints that wouldn't exist necessarily with a computational model, not naturally anyway. And we think that actually that influences the result. And we could discuss that later. Also, there's a very subtle point, the subtle point of uncertainty. So it is the case that when a human draws a particular line, and then the human draws another line, even if you try to do the same line, it's unlikely that it will be exactly the same unless it's a very simple gesture like a straight line. So as soon as you have some curvature, every line you will draw will be unique. And when you watch a result, every trace, even if it's in the same direction and similar overall rendering, every trace has its own character. So how to capture that is very difficult if you approach it from a sort of mathematical or computational way only. But once you have an articulated body to work with, such as a robotic machine, you can actually, by design, include uncertainties that are more related to how the human has to deal also with a machine which has a number of uncertainties in the way you control it. So we think that this notion of uncertainty with the control plan makes us much closer to why a human will draw a particular way. This idea of machines for drawing is a very old one, in fact, using machines or designing various machines. It's been used and designed, machines have been designed mostly in the context of repetitive and more precise drawings for manufacturing, for example. But you have some machines that are more playful, with pendulums, for example, where, again, there you could have some notion of uncertainty in the result. There's even a history of humanoid robots that goes way back. So I think this is the oldest example I'm aware of, but around the 1770s, so about 250 years ago, you have very sophisticated automaton, which are actually programmable. The programming this time is built in hardware, and these are clockmakers, very, very precise clocks. And actually what you see here is the way to reprogram the machine. So every position here is a particular letter, and you can change the sequence of these letters or change the letters, so you can sort of reprogram the machine to then do a particular drawing. The machine is very sophisticated, 6,000 moving pieces, the eyes are moving, looking at the drawing, etc. So I consider it first example of a humanoid robot who can draw or write with a notion of program again. So I'm going to go into some recent projects now, and this is my first major project, me collaborating with an artist, Patrick Tresset, French artist. And this was now we started to work on this project about 10 years ago. And Patrick, I'll say a little more about Patrick later, but he's still a very active, actually much more active artist now, using this notion of machines that draw. And he's incorporated that notion into his own art practice. So over the years, from about 10 to 5 years ago, we ended up creating a first version of a machine we call Paul the Robot. And Patrick continues to use this name, but has actually created many, many versions of more sophisticated of this machine. But you see what it is. Simply, it has an arm, articulated arm. It has a wrist. It can grab a pen. So it has some of the flexibility of your wrist, not as much as a human wrist. Very complicated robotic structure here we have. But this part is more or less similar. These are very simple robots, so they're not very precise, and that's actually a feature, for a good feature. So each time you do a line, this articulation will be controlled, but not very precisely. There'll be a bit of randomness by design in it, which is good for us, and you see the kind of lines you get. And it also has an eye, a camera eye, that can look around and see faces. This early work was focused on faces, and then can look at the drawing and work it into a feedback loop. The very early phase of that project, we start to try to basically, with Patrick, questioning what kind of techniques Patrick was using when he was trying to do a portrait in particular, with very fast gestures. And he had this notion that he had a plan that he would put in his head when looking at someone. And you see here that there's a number of main contours, some notion of orientation of the face, the main features of the face. These lines are not necessarily lines that you draw. This is something you put in your mind, so it's your plan. And then you use that as a scaffold, sort of organization, and you start drawing around or along this plan. And a couple of years later, we had a computational model, and we could do these kinds of rendering which mimic that style of Patrick and give a particular aesthetics that we were pleased with and had some success back then. But if you look closely at the details, you see that the line drawings are not very natural. They're all very repetitive, very precise. In particular, if you look at the angles when you change direction, it's always very, very precise. So you can guess that this is done by, it's a machine system, pure machine system, typical of usual robotics. But this again was done with a software approach. So here's a version where Patrick was trying to go outside of the scope of software only, and these drawings here are done with a pen plotter. So a kind of a machine that moves only in X and Y. And in this particular case, initially he limited himself to do only very round gestures with no very sharp corners in the tracing, and you got a particular, again, aesthetics. But it was starting to be interesting because we had a notion of less precise drawings coming out of using a piece of hardware. And yet, a few years later, we introduce within the what we call the AI-Con for automated iconograph project, this version of what became Paul the Robot. This was first presented in 2010 at an art fair called Kinetica in London, and was very successful in terms of the interest generated. And here's a little video to give you a feel of what Paul the Robot can do or could do, and now can do in more sophisticated versions. So you saw that the eye looked around, saw a face, and now it's going to draw a portrait in the style of Patrick, using the system in place. And this is meant now, it's not just a pure science project, it's actually an art and science project. So there's a lot about what you see here, which is about the theatrical performance. So the artist decides that the drawing will be done in a particular way at a particular speed, which resembles what a human artist would do. There's also a notion that the subject stays and watches the machine doing their portrait, and that's part of the theatrics of the performance. Yes, so what happened after in this project is in the last phase of the project, which is around 2013, 5-6 years ago, we spent more time on this notion of feedback. So we were using the camera eye to look at the drawing, and actually, as the machine was creating a filling of an area, we would measure the qualities of what is done to influence what the machine does next. And this was our first attempt to try to capture this notion of visual feedback that humans naturally have, this capacity, which is not very well understood if you think in terms of now study of intelligence. So we put in place some very simplistic models, again, informed by what the artists think they're doing when they're watching their own drawing and refining it. And there's a paper, a scientific paper on this, so I can point you towards that. This is Patrick. So after that, he started to be asked to demonstrate his robots in different events around the world. And then he decided to establish an actual artistic practice. He had been an artist back in the 90s in the visual field, but he had abandoned that career. And then he basically returned to it thanks to his studies and his robots. And you can look him up. So if you Google Patrick Tresset, you'll see his website, and you'll see where he is showing his machines these days. And he keeps refining these. So there's a continuum of the history that I won't cover here. After my work with Patrick, I was lucky enough to find another artist who engages with technology very well. And with him, we decided to work on the notion of gestures and more precisely this idea of the importance of movement. And we study this, it's ongoing in the area of graffiti art or street art, which intersects with the art of calligraphy. The artist is an Italian, Daniel Berio, and the collaboration also involves currently people in Switzerland in robotics and Professor Plamondon in Montreal, who's an expert of the science of writing and movement, the influence of movement on writing, and also some psychologist, Johan Wagemans in Leuven. This is Daniel. These are some examples of the type of art he's capable of. What's particular about graffiti is that it's made of very rapid gestures. Historically, graffiti is a sort of black art. It's not supposed to be done on building facades. So over the years, artists have developed very rapid ways of creating very beautiful rendering. So there's very high skill for the best of them that we can observe. So that's interesting. We can study with them this notion of skill, how it relates to their gestures. Also, particular there is that they will end up using all kinds of materials and surfaces and very various tools, not just brushes, but even spray paint, for example, because every case is a different surface, different wall. So it's a very diverse type of application on the practice side. And again, for us, on the science, we want to study, take this discipline and study the dynamics of movement and see how it relates to quality. So on the science side, I won't give you mathematics here, but there is some strong, well-established mathematical model. It's called the sigma log normal model. It comes from a science called graphonomy, which, if you look at the history of graphonomy, it started by studying, in particular, signatures. And back in the 80s, 90s, this science was producing results so that you could verify, for example, automatically that this is your signature when you sign a check, for example. But out of this area, very practical, engineering type scientific area, came up some very simple and accurate models that relate a trace with the speed profile of what movement you will tend to use. And the plots that you see below relate to the speed profiles of these different traces. So here in particular, you see that you start from a particular point, we call a target, to another target. The target might be the same, but the orientation might be different and the speed might be different, and this will influence where the ink is traced. So just to give you a better feeling for that, here you have 3 examples. You have the same targets. You're starting from one point, you're aiming at another, and then you finish yet at another. They're all the same plan. So in terms of robotics, it would be the same plan each time, how you're going to use your arm. But you simply change the speed you allow. And because you, for example, you want to go really fast, you will not reach the corner. So there's a relation between, for example, how accurate you will reach a corner and change angle and the speed that you have to use when you manipulate your arm. And essentially, you have to reduce temporarily your speed if you want to reach a corner and have a sharp angle. And these plots, you see that they start overlapping. When they overlap, it means that each gesture is closely related, and you will not be able to do a sharp corner. And then we can apply this and study traces that are complicated in the context of graffiti. So here are some examples. This gives you actually more background on the art of graffiti. I see I have about 5 minutes, so I'm going to speed up, but hopefully I can cover all the material I wanted to cover. Here's a typical graffiti. Other example. It's not just traces, it's also 2D structures, so there's more about form we could talk about in this context of graffiti, but I won't cover that. I'm only covering these simple traces today. So initially, a few years ago, with Daniel Berrio, we put a system which is purely computational. It's using this model sigma log normal of speed. You saw that you had a little plot here. That was the speed profile that could be varied, and you see it here again. And you have a very nice interface to create various designs. And then you can see that you can render it with a movement which is credible. That is, the movement is based on the science of how humans move. So you can expect that the movement is alike what a human would do. You can also do, you can beautify a trace. You saw that there was a very shaky set of targets there. And then it's beautified with the model, because the model actually relates to what an expert would do rather than just a naive starter draftman. Yeah, so I could say more about this technique, but I will skip few details, just there's only a few minutes left. So once we have good computational models, then our method, if you remember, is then we can try to port these on machines. So we did that. This was an early example. Here we're just testing whether the speed model we have is actually coherent with a real artist. So this is Daniel actually doing a particular signature here, particular form, and the machine is following him. Not exactly, but it's quite close. We were happy with the result back then. And we started to work with Sylvain Calinon in Switzerland, who's a specialist in robotics, and with him, in their lab, we work with this particular humanoid robot. It's a Baxter. You see that there are 3 targets. Initially, the machine is making errors, and here the machine is able to learn from its errors and improve the quality of the trace. That side of learning, that comes from the specialist Sylvain Calinon. He's done a lot of work in this area. And we're providing the way to refine the trace in terms of movements. So eventually the robot can draw and sign their own name. So my conclusion is here in a few summary points. This research, I think, allows us to study, and from the artistic point of view, possibly even extend human creativity. By that I mean that actually artists can use the results and then create possibly a new practice. Patrick Tressé is a good example of that. We're actually, I think, demonstrating that we can understand in more depth some aspects of an artistic production and understand techniques and skill. I believe from my point of view that this gives us a good way, a window into intelligence. I put up there a good way to study some aspects of human intelligence and relate creativity to movement in our particular case. And then in the future, I hope that this sort of research gives us ways to talk about differences between culture. The team at the moment involves Daniel Berrio, I mentioned. A new person joined the team. Jarosław Lokieto is a Polish robotics specialist. Sylvain Calinon is a robotics specialist who studies learning in Switzerland. Régent Plamondon is a specialist of signing and movement, and myself. Thank you very much. Sorry, questions at the break, please. Thank you.